very good morning, students. So, today I am here again for the lecture number 4 of the States of Matter, chapter 5. Let's start with the quote, and the quote is this: Be a self starter and a self motivator. Do you like your car being pushed every morning? If not so, then why should you expect someone else to keep asking and reminding you to do your job? So I don't think so. I have to explain it. There is no explanation needed over here. The line itself is quite enough to explain the things. Yes. So I will always. I wish to that you people will be a self starter and a self motivator. So let's start with the lecture. And today we are going to do the combined gas law and the ideal gas equation. So here is some you can say that GIF how it is. Charles law is this: V1 upon T1 is equal to V2 upon T2. Gay-Lussac law is P1 upon T1 is equal to P2 upon T2. And we have Boyle's law, that is P1 V1 is equal to P2 V2. So just combine all this and you are going to get P1 V1 upon T1 is equal to P2 V2 upon T2, isn't it? So this is the law, combined gas law. Combined gas law, Boyle's and Charles law give separately varieties of the volume of a gas with pressure and temperature, and that we have discussed already. Yes. By combining these two laws, we get an equation which gives the simultaneous effect of the change of pressure and temperature on the volume of the gas. When we combine this, though, we can get the effect, like what is the like simultaneous effect on the pressure and temperature on the volume of the gas. If we increase the pressure and increase the temperature, what will be the volume, or somewhat like in vice versa way. So this is known as combined gas law or the gas equation. How to prove that? So combined gas law considered a known quantity of a gas at pressure P1, temperature T1 and having volume V1. Suppose that it is to be converted to another state, whatever the state it is, having pressure P2, volume V2 and temperature T2. Then the gas equation can be derived as follows. Let us change the pressure of, let us think that change of the pressure of gas is from P1 to P2. Pressure is changing at a constant temperature T1, and the volume will change from V1 to, now the volume will be Vx. Okay. Since the temperature remains constant, therefore by applying Boyle's law, we can say that P1 V1 is equal to P2 V2, and here V2 I have assume as a Vx, isn't it? So can I say Vx will be P1 V1 upon P2? Yes. So now next thing, step 2. Let the temperature of the gas now change to T2 at constant pressure. Now we are going to keep the pressure constant and temperature will be changed. Okay. So T1 to T2 temperature change. Pressure is remaining constant, and that pressure is P2. So that the volume may change from Vx to V2. Did you get that? Initially it was V1. First V1 से Vx में convert हुआ and then Vx to V2 में convert हुआ. So V1 to Vx जो हुआ, that is converted in converted at constant temperature. Okay, but Vx से V2 जो convert हो रहा है, that is at the constant pressure. You get that? Volume is changing from Vx to V2. So according to Charles law, use the Charles law here, and you will know that V1 upon T1 and Vx upon T1 is equal to V2 upon T2. So can we find that V2? V2 will be Vx T2 upon T1. V2 is equal to Vx T2 upon T1. So now put the value of V2 from this, Vx from this, put the value of Vx from the equation 1 in this. We will get what? V2 is equal to Vx was this P1 V1 upon P2, and this is T2 upon T1. Just put it like this. So what you will get? After rearranging, we can get this P1 V1 upon T1 is equal to P2 V2 upon T2. Yes or no? And this is called combined gas law. Did you get that? What happened? How we have changed? In the first step, I kept the temperature constant, and in the second step, I kept the pressure constant. Then only we can apply the Charles law and the Boyle's law. Yes. So now you can see that initial state was P1, V1 and T1. Here the temperature remains constant. This is the step 1. So what happened? P1 becomes P2, V1 becomes Vx, which is V, we can see, and T1 remains constant. Nothing change in this. P1 and V1 में changes हुआ. Next, step 2, pressure we are going to keep constant. So pressure is P2, so it will remaining constant over here. Yes, P2, and Vx becomes V2 and T1 becomes T2. So this is the initial and final stage, and it happens in this step 2. Here temperature constant, that means we applied Boyle's law, and here pressure constant, that means we applied Charles' law. Yes, so I hope it is clear. Now, derivation of ideal gas equation. Ideal gas equation, what before that you should know that ideal gas. What is this ideal gas? So, ideal gas is said as the gases which behaves as, which follows the Charles law, Boyle's law, and that means all the gas law at all condition of temperature and pressure. They are called ideal gas. Got it? The gas which follows the Charles law, or which follows the all gas law at all the condition of temperature and pressure, they are called ideal gas equation. But we know that unfortunately nothing is perfect in the universe. Yes, so gas equation can be derived by combining Boyle's law and Charles law, and as well as Avogadro law. For the ideal gas equation, we have to use Charles law, Boyle's law, and Avogadro law. I have explained that what is ideal gas. So I was telling that unfortunately nothing is perfect. That means nothing is ideal gas, but real things are there. So the gases which cannot behave as a ideal gas, or which cannot follow the gas law at all the condition of temperature and pressure, that are called real gas. That means कुछ certain condition they will follow, but some certain condition they won't follow. Yes, so that is called real gas. So actually real gas ही होता है. If I will say that what are the condition when the real gas can act as a ideal gas, so that can be the condition. If they follow the condition, they will be considered as ideal gas, isn't it? Let's move to this. According to Boyle's law, for a fixed mass of a gas at constant temperature, we know that volume is inversely proportional to P. And here what I have kept to constant T and number of moles. Now, according to Charles law, if you see, this is the volume is directly proportional to temperature at constant pressure and N. So, can I see V is directly proportional to T upon P? Combine करके, yes. And Avogadro law is V is directly proportional to N, constant P and T. So, just combine all this. What you will get NT upon P, isn't it? V is directly proportional to NT upon P. Yes, this one. And we very well know this thing that whenever we remove the proportionality sign, we are supposed to put a constant, and that constant is here R, and this is called universal gas constant. This R is universal gas constant, where R is a constant of proportionality and is also known as molar gas constant. The value of R is same for all gases. ये हमेशा constant रहता है. That's why it is known as constant, and it is also known as universal gas constant. And the value of R that we have to learn, different unit, different R value are there, so that you have to learn. I will tell you. So this is, we got that ideal gas equation where PV is equal to nRT. कैसे आया? Just move to this next slide. Here it is. PV is V is directly proportional to NT upon P. So can I say PV is directly proportional to NT? Remove the proportionality sign, we put a constant, so PV is equal to nRT. And this equation is called ideal gas equation. That means all the ideal gas equation follows this. PV is equal to nRT. This is also called as ideal gas equation, where P is pressure, V is volume, N is equal to number of moles, R is equal to gas constant, which always remains constant, and T is temperature. Yes. Ideal gas equation is equal to PV is equal to nRT, and the above equation is known as ideal gas equation. And here the important point, let me mark it. The word ideal is used because there is no actual gas which completely obeys this equation. However, the real gases, this is the real gases which are not ideal, they are called real gases, behave ideally at high temperature and low pressure. So this is the condition when the real gas can behave as an ideal gas. What is the condition? That should be high temperature and low pressure. Did you get that? Okay, since the ideal gas equation expresses the quantitative relationship between four variables, that is P, V, and T, all the four variables are there, that describe the state of a gas, it is also known as equation of state for gases. because it explains all the four variables: pressure, volume, number of moles, and temperature. So that's why it is also known as equation of state for gases. Now, the numerical value of R depends upon the unit in which pressure and volume are expressed. That means R value जो होता है, that depends upon pressure and volume की unit पे depend करता है. And you have to learn. There was a fixed thing like we have done the thermodynamics where I told you that R value is always 8.314, isn't it? So, but in this case, states of matter, we have different R values and we have to use that and we have to learn that. So here are the different unit. If the volume is in liter, pressure is in atm. So what unit you have to learn, that I'm going to tell you. This is 0.0821 liter atmosphere per Kelvin per mole. When the volume is in liter and the pressure is in atm, then this unit should be used. Yes. Next unit is you have to learn this 8.314 joule per Kelvin per mole. This one, when that the pressure is in newton per meter square. Okay, so then R value should be this. ये आपको याद करना होगा. Okay, and volume is in meter cube. So this is the formula you have to learn. And one more is there that is not written over here. That is 0.083. It will be 0.083 यहाँ liter, and this will be ATM की जगह पे वो bar आ जाएगा. That's it. Okay. So either you use in ATM or bar, it's almost same value, so there is no problem at all. Okay, these are the two values which are very important. You have to learn. Different units are there. If basically these are not used in that numerical, but if it is asked according to the physics unit and dimension, you can convert the unit very easily, I hope. So by that way you can convert it. Okay. So these are the two values that you have to learn. Actually, next there is a question waiting for you. So let's start the question. A sample of nitrogen occupies volume of 1 liter at a pressure of 0.5 bar at 40 degrees. So what are the things given? Just write down and find the next thing. That means volume is given, pressure is given, temperature is given. आपसे next pressure पूछा जा रहा है if the volume is this and the temperature is this. So obviously which law? Combined gas law. P1 V1 upon T1 is equal to P2 V2 upon T2. But don't forget to convert the temperature in Kelvin. Otherwise it will be wrong. Yes. So I have converted that. It is one is in liter, another is in milliliter. So converted this volume also in the where is that? This value also in the liter. Yes. And then temperature, don't forget to convert this. So it is -6 degrees. So that's why the temperature will be 267 Kelvin. And the first one is 313 Kelvin. So P1 V1 upon T1 is equal to P2 V2 upon T2. And just put the value and get the answer. The answer will be 1895.6 bar. Why I have used here bar? Because the pressure is given in the bar. And other unit will be cancelled out, isn't it? Liter, Kelvin, all the unit will be cancelled out. Only bar will be left. The pressure unit is bar. Did you get that? So 0.05 bars, it will be converted into 1895.6 bar. Is it correct? Okay. Next question is here. At 25 degrees Celsius and 760 mm Hg of pressure, a gas occupies 600 ml volume. What will be its pressure of a height? Pressure at a height. Sorry. It's not off, it will be at a height where the temperature is 10 degree and the volume of the gas is this ml. Okay? So volume V1 is given, V2 is given, T1 is given, T2 is given, P1 is here, P2 is asked. So simple, again the same formula you will use and no need to change anything because all the units are in the same one, but just Kelvin. Degree Celsius should be converted into Kelvin. That's it. And again use the formula, put the value and get the answer 760.6 mm of Hg. I hope it is clear. Okay, now next question is here, that is calculate the volume in decimeter cube. Occupied decimeter cube, that means 1 milliliter. Okay, 1 decimeter cube is equal to milliliter. Occupied by this molecules of oxygen at 27 degree having a pressure. So here number of molecules is given. pressure is given and temperature is given and आपसे पूछा जा रहा है volume क्या होगा. So which formula? PV is equal to nRT. Use this formula and get this. Here the number of molecules is this much. Pressure is given. Temperature is we have converted. R key value we know that. Since here it is in decimeter cube, so we have to use that value. Okay, so that is bar per milliliter, or like we can use this. Just check that value from our from that table and use this. Otherwise, if there's something like different value we are using, it will be generally given to you in the question. Yes. Now, so here number of moles, say one thing, here it is molecule given, but n is equal to number of moles. So you have to convert this number of molecules into number of moles by using the formula number of molecules is equal to moles into Avogadro number. That formula you know. So number of molecules will be number of moles will be number of molecules upon Avogadro number. Isn't it? You know the formula we have done in the first chapter. Number of molecules is equal to number of moles into Avogadro number. This is the formula. Yes. So use that formula and I got the number of moles 0.672 mole. Isn't it? Now use this. PV is equal to nRT. Pressure is given 0.933 bar. Volume you have to find. N is equal to 0.672. R की value given है. T की value you got it. Just put this and you get the answer. That will be 17.93 decimeter cube. Clear? Okay. Now next question is, a discharge tube of 2 liter capacity containing hydrogen gas was evacuated till the pressure inside is this much. That means this was the volume, और तब तक इसको evacuate किया गया जब तक इसका pressure total ये ना हो गया. If the tube is maintained at the temperature of 27 degree, calculate the number of hydrogen molecules still present in the tube. So that is quite easy. Again, you have to use the formula ideal gas equation, and moles को find करने के लिए first moles you know, n is equal to, you will find that number of moles and then convert it into molecule, you will get it. So pressure is given 1 into 10 to the minus 5 atm. Volume is given 2 liter. R key value according to atm and liter, it will be 0.02 atm liter per mole per Kelvin. Temperature is this and number of moles you find it. So first you find the number of moles you will find using this formula 8.1 into 10 to the minus 7 mole, and now you got the mole, so just multiply by Avogadro number, you will get the number of molecules, isn't it? So molecules ke liye we know that multiply by this Avogadro number, and here we got this 4.879 into 10 to the 17 molecules. I hope it is clear. Any doubt in this? Direct formula based questions are there, so I don't think so that there will be a problem. Now the next question, and this question is little bit application based. So a drain cleaner, it is of your NCERT. A drain cleaner contains small bits of aluminium which react with the caustic soda to produce dihydrogen gas. So before that you should know that caustic soda kya hai, and you have to write the equation also, because it is going to help you to find the number of moles. So what volume of dihydrogen at 20 degree? This is degree. Okay, let me write. This is 20 degree, not here. And 1 bar pressure. So pressure is given 1 bar. Will be released when 0.15 gram of aluminium reacts. So you have to find the number of moles kitna hai. So for this you are supposed to write the equation first. So write it. Caustic soda is sodium hydroxide. So 2L plus NaOH plus 2H2F will do this. It will give you sodium aluminate and hydrogen gas produce karega. Now you will ask ye reaction kaise hua? So just learn class 10th. You have done this reaction of metal with the base. Yes, so this is the 3 moles H2 gas is liberating. So where we can say that 2 into 27 gram, this much gram of aluminium is liberating this ml of 3 into, because 1 mole ki volume hota 22400 milliliter. So 3 moles, so that's why this milliliter volume it is liberating. So 0.15 kitna volume liberate karega, that you have to find first. It is known that 1 mole of any gas at 0 degree and 1 bar pressure occupies 22.4 liter or 22400 milliliter. So 54 gram of aluminium gives this liter So I have 0.15 grams. So 0.15 कितना देगा? 3 into 22.4 upon 1.15 you will do. Sorry, 3.3 into 224 divided by 54 multiplied by 0.15. Yes, you will do this. This is the answer. We got it. एक second, I should not write it here. इसको यहाँ पे ना लिख के let me mark it as a question. Okay, so how much unitary method you can apply? 3 into 2 to 4 divided by 54 multiplied by 0.15 and you will get this much liter it will give. So you got the volume. Yes, you have temperature, you know the R value, and आपको यहाँ पे क्या करना है? What volume आपको find करना है. 1 second. What volume of dihydrogen at 20 degrees Celsius and 1 bar pressure is given, will be released this. So what you will do? So here we can say that simple 0.189 liter pressure will be released at 1 bar pressure at 273 Kelvin. Got it? अब यहाँ पे आगे चीजें आपको करनी है. कह रहा है what volume of dihydrogen at 20 degree Celsius कितना होगा? So pressure is given 1 bar. अब यहाँ पे देखते हैं. Now this is the continuation. So calculate the volume of H2 at 20 degrees Celsius at 1 bar. What is this? What formula you will apply here? That is P is equal to 1 bar, P2 is equal to, because pressure is going to be constant, pressure is not going to change. So volume is going to change, isn't it? Because volume was, first we got the volume. We got the volume over here, na 0.189. The volume is going to be changed, isn't it? And temperature is earlier it was 0 degrees Celsius and now it is 20 degrees. So 293 we will consider. So P1 V1 upon T2 is equal to P2 V2 upon T2. That is the combined gas law. Use this formula and get the volume V2. So I hope you will get it. That calculation you can do and you can get it. So it is 0.2028 liter, or you can say that 202.8 milliliter. Is that clear? If it is not clear, just watch that again. Okay, so that is the answer, 202.8 milliliter. Now next question is here. Calculate the temperature of 4 moles of a gas occupying 5 decimeter cube at 3.32 bar. It's a straightforward question. Pressure is given, volume is given, N is given, R you know that, temperature is asked. Yes, but यहाँ पे ध्यान रखना है कि which R value you have to use. This is bar, decimeter cube you have to use. So pressure is given, bar decimeter cube 0.082 or 83 होता है, so that you can use, and number of moles is given here. So use this PV is equal to nRT and T you can get it 50 Kelvin. Don't convert the unit. अगर unit convert करना भूल, don't forget to convert the unit. अगर if you will not convert the unit, it will not be like solved, और ये answer आपका वहाँ पे क्या होगा, confusing हो जाएगा. So that's why it is very very carefully you have to change the unit also. So that's it for today, and we have covered with this ideal gas equation, and the major part of the states of matter is finished, the gaseous thing. Something we have to do, that liquefaction of gas and all that we will do in the next class. So watch the video properly and do solve the numericals by your own, because it is straight questions, it is straightforward questions. So once you will try, you will get it. So we'll meet you in next video. Till then, thank you class. Enjoy your study.